I'll sit back and send the link. Be able to look at this video again just to make sure that you're understanding it. If you need to worry about how's it going to go in class on Monday.
Okay.
All right. So question number 1, right? It's saying terminology. Now we're on multiple regression, and it's asking using the height, right? Tail length, kick force, and weights of kangaroos, we get this regression equation, right? So equals negative 100 plus 96 height plus 43.5 tail length plus 73.5 kick force. They want you to identify the response and predictor variables. So the response and then the predictor variables. Now, in order to do this, you just kind of got to know kind of what this is set up as.
Right.
There is really looking up here, like right here.
And then the other one is, yeah, that's what I put.
All right, the height and then the predictors. Right now, here's the issue though. Since you're teaching people who aren't reading, right? When you get to this, you can sit back and highlight this, or you can move on to the next slide. And the next slide actually has a segment of the chapter that's letting them know this. I like to do this so that people aren't like, how do I supposed to know this, et cetera, right? But it's just talking about a multiple regression equation. It expresses a linear relationship between a response variable, key right here, y, and 2 or more predictor variables. And that's like x1, x2, xk, all the way up to what they want, right? So seeing the similarities between these two, you can identify from this right here that weight is a response, and then the predictor variables are all of the additional 3.
Right.
All right, any questions on that?
No, it's pretty clear. It's just like terms.
Now I will send you this PowerPoint so that you can use it. And let me ask you, are you comfortable using the annotations feature on the annotation feature on Zoom?
Like drawing, yeah. I'm gonna tell you a funny story, right, Dr. Barnes? I was in class with Dr. I think I named like Eva. I was in her class or whatever, and I didn't know that if I wrote it on my screen, it came up on her screen too. So I had did the little drawing. She was like, "Oh my God, who just did that?" I erased it so fast. It was so funny.
Yeah. All right. So you definitely know how to do it. Question number 2, right, is best multiple regression equation. For the regression equation given in exercise 1, right, the p-value is 0.019, and the adjusted r-squared value is 0.834. Right, so that's the one from exercise 1 that had tail length, height, and kick force. If you want, let me see. Let me do this right here. Yeah, you can remind them of tail length, height, and kick force, right? Which is what we were talking about in terms of exercise 1, right? If you were to include an additional predictor of neck size, right? The p-value becomes 0.026, and the adjusted r-squared becomes 0.873. The adjusted r-squared value is of 0.873, right? That's what we're saying right here. You add a fourth one, is greater than the 0.834, right? Which regression equation should be used? Now, if they read this, they should know this, but I kind of talk about this in class as well, right? When you do some gains in terms of finding out whether it's better to do something again, you got to calculate the gains, right? And then the gain is what I'm talking about is in terms of between those two numbers, 0.837 to 0.8. Yeah, I got the numbers wrong. I'll fix this on your presentation. You got to calculate gains right here. Say again?
The other way around. It's supposed to be the other way around.
Yeah, I guess I was a little dyslexic when I was doing this. It should be 873, right? Where this says 837.
873?
Yeah, so I'll fix that in the I'll fix that before I send it to you. Right? But it always says the rule that we have in class is the gains must be greater than 0.5, right? So we're using that same 0.5 that we always use, right? And when we calculate the gain with these two, we're taking the 0.873 and we're taking the 0.834, subtracting them. And since that gain is not greater than 0.5, you can see 0.39 is less than 0.5. The gains benefit is not worth adding a fourth predictor. That's essentially what we're saying. It's not worth doing a model that has a fourth predictor by adding next size, because the benefit isn't a lot. The benefit is less than 0.05. Right, so I will have this in here. I can actually fix what I got right now. Clear all. Boom, there we go. The math is actually.
Hold on. Dr. Barnes, did you change that? Because I'm looking at a different problem for number 2.
Oh, yes. And here's the issue. Yeah, you got to look at the essence of statistics section of the course, right? If you're looking at that, you're looking at the actual homework, right? What we do for essence of statistics is we create questions that are similar.
Oh, to them. Okay.
They're not the exact same one. So if you look at it, it probably says best multiple regression equation. The problem might look a little bit different. It's probably not talking about a kangaroo and stuff, but the thought process behind it is still the same. And this solution right here is also still the same. You know, again, it might be different in the book, whereas if the gains is greater than 0.5, then you would go the other way around. You would think it's better to add a fourth predictor. But right here, it's not worth it. That makes sense?
Yeah. Okay. So, because I'm looking at the bottom where it says gains are calculated using the 0.873 minus 0.834. And the 34 came from, okay. I'm just.
Yeah, no, right here. I'll show you. We're talking, when you read this problem, right? The regression equation for exercise 1, p-value is this, and the adjusted R is the 0.834. So it was in that.
So even if the numbers is different, it's still the same concept, right?
Exactly. That's exactly what I'm trying to tell you. So when you're going in class on Monday and you're telling them how to do this, if they do something like this for the homework problem and they separate what it was into where it changes to, right? But it actually is greater than 0.5, then they would say it's worth it.
Right.
Yes, it's the logic. We're teaching them the logic, not giving them the answers to the homework.
Okay.
All right. Let me see. Let me clear this real quick. All right. So that's the second problem. Then we got problem number 4. And this is talking about interpreting R squared. We ask you to interpret each of the provided multiple coefficients of determination and indicate the percent of variation that can be explained. Now, do you know how to answer this or what to do with these?
No, because I didn't answer this question.
Okay, it's a little bit different. All right, let me see if I can find the answer in the textbook, because I need to copy it and put it in here anyway. Yeah, let me go back. it's not there. Yes, here it is. Now, what this says is this. This is the paragraph that's going to be relevant to what we're doing right now. Let me get this out the way or move it. We got to move it, right? When you look in here, print screen. When you read this right here, it's saying a very poor fit of the model is an R squared close to 0, right? So if the value is close to the value of R squared equals 0.878, right? It indicates that 87.8% of the variation can be explained by their heights and weights, right? So that's the line that is relevant to this. If you read it and you're sitting back there and understanding how the multiple coefficient of determination works, it's letting you know that the 87 or an R squared of 0.878 translates to meaning you can explain 87.8%. All right, so let me print screen this. All right. All right. Let me put this in the PowerPoint. All right. So I'm going to shrink this a little bit. You can show them the problem, right? And then we'll have this added to the bottom.
Okay.
And this is what you will read to them. And it's from the textbook, and you can highlight it just like we did before, just to kind of highlight the aspect of it that answers this question. All right, let me get rid of this. Okay. Yep. So reading this aspect right here of the presentation will kind of let them know where you're getting this answer from. So I would kind of have it up on the screen like this, and either try to get someone to read it for you or to go aspect. But the very important part is, like, you could say, if I'm trying to understand it, a perfect fit would be R squared equals 1, right? A very poor fit results in a value of R squared close to 0.
Right.
But then it goes into detail that says the value of R squared equals this, pretty much translates into 87% of the variation of weights can be explained. Right now, that's going to be important because I'm giving right here for this problem that I made up, I'm giving people 3 R values. R value of this, R value of that, R value of this right here. And once you get that to them, they'll be able to know that the answer should be, sit back and go over them. The first one's probably 72.7%, 83.4%, and then 25.2%. There you go. Let me do something else real quick. No fill. Outline should be red. I think it's outline a little heavy. All right. So when you go here, it's like the question, asking people if they know the answers. Then when you move to the next slide, what you need to have them know in order to answer it is on the screen, and then you can go from there.
Okay.
All right, you good?
Mm.
You good?
Yeah.
Okay. All right. Now this right here is kind of a duplicate activity of exactly what's in the back of the book. That there's no deviations right here, right? But it's asking for a couple of things. One, it's saying identify the following, right? The multiple regression equation. That's an ugly color, my bad. Right? Now to get that, the multiple regression equation, it's all the information up here. This is the y-intercept. And each of these, boom, 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 those are the estimates of the predictor variables, right? So what you would do is this. You would sit back there and write your equation. We do this. Y hat equals negative 3.64 plus 0.367, which we get right here,
Right.
plus negative 0.419, which we get right here, plus 0.589, which of course we get right there. The only thing missing after that is just writing the, what you need, x sub 1, x sub 2, and then x sub 3 to refer to order speed, customer ratio, and then cleanliness.
Okay.
All right, so that's the first one down. Now, you know what? I guess I need to figure out if there's anything in, there might be. Let me go see if I can find it. Let me see. Get rid of this, is in my way. That's an example of, yeah, but it's not in Excel. Let me go to section 10.2. I think it might be a picture in 10.2. Yes. Yep. So, you know, they don't exactly have it, but yeah, I'll do this anyway. All right, so I'm going to do this, print screen, get another grab for you. Crop it. All right. So going back to this right here, best thing I would say is let's do another duplicate slide. We can shrink this down a little bit and remind them of what was in the previous chapter. And when you remind them of this right here,
Mm-hmm.
let me see. You can let them know that it's not 100% there because this is something that's new. Like they haven't showed this to you before, but you just use the same logic and it's the best solution that they could go with. Let me see. All right, let me put this up on the screen so I can show you how it works out. Right, this is just an example of from chapter 10.1. I should write that in here somewhere, right? All of these technologies show that the regression equation can be expressed as negative 3.37 plus 2.49x, right? Now, look at all of these. The information is just kind of listed in here, right? So we got right here is where we get the negative 0.37. It's just rounded, plus the 2.49, which matches this. This right here listed this way, right? This process right here also listed out mini tab. TI 8384 calculator listed right here. And then B is right here, the 2.49. StatCrunch is another software that uses it. It's just kind of listed right there for you. JMP, this is one that can kind of help, right? Because it has intercept, which is what Excel did. Excel had the intercept and that was the slope, right? I'm sorry, the y-intercept. And then the thing for chocolate was 2.49. So it's really just showing them that, you know, we've done this before with other forms of technology, and that's kind of ones that really help. I'll be honest, this right here is the best one to kind of really highlight and focus, because if you paid attention to this is the one that referred to the y-intercept as intercept. Oh, no, hold on. So does this. Yeah, so both of these refer to the y-intercept as intercept. So it's not too much of a stretch, right? To we go back to this slide. Not too much of a stretch when we see this right here saying intercept, that would probably be the intercept to help you do that equation like we were doing. All right. I think that's good too. All right. Now there's three things on this, right? Then we're asking for the value of the multiple coefficient determination R square. I'm pretty sure you can see that. It's at the very bottom. Right here, R squared. And the value is 0.613. And then it's asking for the value of the adjusted
R squared
value. And of course, their R square adjusted. And it's just looking. Yeah, it could be talking about the p-value, but we're not going to worry about that. If you're comfortable, this is really up to you, right? I'm not going to be there, and I think it's not really going on with the questions, but you could pose the question about whether it's a good model. And this is a good model because the p-value, which is right here, that 0.043 is less than 0.05, which makes it a good model.
So you said you want like X, is it a good model?
Yep. But again, don't worry about that. I wouldn't go anywhere deeper than what you have. Trust me, I think you have followed me on everything that I'm doing right now. There's no reason to sit back and make it more complicated and try to remember like a point. That's what I do as an instructor.
Okay.
Yeah, so don't worry about that. All right, clear all. All right, we're almost done. Now I think what I'm gonna do is this. I'm gonna have this slide right here, right, which shows you this problem. Then I'm gonna give you this so that you can leave it and show them kind of like how it was exampled. And then I'm gonna have this slide again.
Okay, just so I don't have to go back.
Yeah, so you don't have to go backwards. You can always kind of go forward. All right, and I got it right now. I'm sitting here thinking I gotta do it later. I can do it right now. So to be here, here's the problem, have them read it. this is what we read before to sit back and know how to do it. This was back in chapter 10.1. And then you can kind of highlight the things that are relevant. And then you go back to the problem, and then all the information is right here for you.
Okay.
All right, now here's another big one. Right? I don't think it's that big, but it's a lot on this page, right? News source, right? So it's saying finding the best multiple regression equation, refer to the accompanying table, blah, blah, blah. The response variable is the way students at Cheney University obtain their news. The predictor variables are TV, which stands for television, NSP, which stands for newspaper, and SM, which stands for social media.
Social media.
Yep. Right now, this table has almost everything you need on here. It has social media equation. This right here is the y-intercept plus the slope if you're only using one predictor. Same thing for newspaper. That's the intercept slope if you're only using that. But then it gets a little complex and it's matching these pairs up, right? So if you're trying to use two of them, and then at the very top, that's when you're trying to use three of them. Right now, let's see if you remember this. We talked about before about the whole gains, right? If you're going to use a model that has more variables, you need to use the gains. Like you need to calculate the gains. What the gain has to be greater than in order for you to think it's used.
Wait, what did you say?
All right, I mentioned before, in order for you to go from like one variable to two variables, right? Two variables to three, we got to look at our R values. And we talk about the gains. Right? What did I say that the gain has to be greater than in order for it to be worth using an additional predictor variable?
0.050.
0.05. Yep. So it's 0.05. Right. So let's look at this. Right now, let's first start off by looking at the
singles.
Yeah. Now the first question is saying if only one predictor, which single variable is the best? You know which one's the best?
The smartphone.
I just want to make sure you get used to it. You say you can do it, right? But how about this? I'm going to let you do screen and narrate. You identify or highlight the variable that is actually the best one.
Okay. They don't let me like highlight or anything.
You
just
sure?
let me
underline if you can, but I think if you get in there and look at it, the options are there.
Okay, I see it now. Okay. Okay.
So question number 9, you know, I always like to sit back and focus on highlighting the part of them, which is really important.
If only one predictor variable, we got like that because we're talking about one, right?
Perfect. Yeah.
Okay. And the variable is used to predict the consumption of news stories. Which single variable is best and why? I like to put that. This is the question. And then I would say.
All right, you're breaking up. I'm not sure what you said. You might want to repeat that.
Wouldn't it be the smartphone? I said, isn't it the smartphone?
Yeah. Or no, SM is social media.
Oh, social media. I said smartphone.
Yeah, it's all good. Trust people would get it. People would get it. All right. Now, do you know why? Why is it that?
Because I wrote this thing. I did this question. It has the because it has the highest adjusted R square value.
Okay. Yep. It also should have the highest R square value too. Either one you look at works. Right. So you're right there. You definitely got that one. All right. Number 10, kind of same function.
Okay. If exactly Two predictive variables. That was horrible.
Don't worry about it.
Variables are used to predict the consumption of news stories. Which two variables should be chosen and why? This one will go to, I'm looking, TV and social media.
Yep.
Because of the same reason of the last problem.
Yeah, you got it. You got it. And the only thing I would probably do is just make sure you talk to them. Remember, you're trying to teach them to let them know that, like, you know, this number is the highest. You can either say that the 0.992 is higher than the rest, right? Or you can go through and highlight it.
Okay.
Either way. Okay. Then the last one is saying which regression equation is best for predicting the consumption of news stories.
Isn't it better to use the regression equation with only one variable?
All right, but again, what did we say? You got to calculate what? You got to calculate
the gains.
Gain, right? Now, you can easily look at the gains, right? But for this class, you got to look at it. If you look at social media, let me highlight it. I'll take over for a little bit. Right? When you look at what we have right here versus what we have right there, if we calculate those gains, that's much higher than 0.05. So as a result, it's worth it to go from 1 to 2. Right? Then the issue is since we're saying we're at number 2 right here, let's look at the benefit of going to 2 to 3, right? When you calculate the gains of this, that's actually 0.004. That's way less than 0.05. So it's not worth it to go to 3, but it is worth it to go to 1.
2.
Yep, and it's this one.
Okay.
That's a lot of critical thinking and all that kind of stuff that's in there. But like, again, I think you have that.
Okay, so my first question is, what time the Zoom? Or are you joining at all?
I'm sorry, say again?
I said, or are you not joining at all because of the meeting?
Yeah, I probably won't be there at all. Now, here's the thing. I might log in, right? But don't let me logging in distract you because I'm going to be in another meeting, right? I actually think I need to talk and kind of organize the meeting. So I won't be able to chat, but I might be in there in the event that something goes wrong or, you know, students being disrespectful or something. But I might have my phone logged in just to kind of see what's going on.
Okay.
But yeah, if I'm not talking to you or anything, that's my and actually you can let the class know that I'm in a meeting so I can't talk just in case somebody's trying to, Dr. Barnes, I need help with my homework or something. Yeah, you can let them know, like, look, Dr. Barnes not on the other side of that phone.
So I can just join the regular Zoom meeting and then just share my screen.
Exactly. I'll send you this, right? Which is in a good format. Now, the only thing we got to do is this last problem. I actually am going to give you a new slide for this last problem. Let me go and get rid of this. Other ones I think you're able to use the screen for, right? Exactly how it is. But let me do, let me make another one for when you're writing a regression equation. So you have some space to do so.
Okay.
Okay, so this is saying the last one, Essence Frazier, the best statistics student ever, right? Watches 4.5 hours of television and 6.5 hours of social media. What is the best predicted value of her consumption of news stories? You know how to do that?
Okay, so first you look at the chart and look at, hold on, I'm gonna highlight it so you know where I'm going with this. She watches 4.5 hours of television and 6.5 hours of social media. So you will plug that into this equation. And hold on. When you do that, you get 4.32 plus next point. I write too big. It's not gonna work.
Yeah,
out.
you know what? Here's the issue. You might you got the other pen. Go back and use the other pen. There's another pen that's a little smaller than that, I think. There you go.
Okay, yeah.
Okay.
And just solve for that, right?
Yep. And you know what? I would probably sit back and this is probably the hardest math that you have to do. So what I might tell you to do is get a piece of paper, solve it. Let me tell you, it can be very nerving if you're in class trying to solve this, even though you know how to do it, but what's going on. So the one thing I might tell you to do is to write this problem down, solve it, so that on the other end, you can pretend like you're doing it, right? But you actually really have it on a piece of paper next to you.
Okay.
Yeah, and that is it. I'm so sorry. I know I don't want to get up, but I know my microphone's taking this video game in real quick. Let me see.
It's fine.
Yeah. That is it, Thomasina. I mean, I don't think there's any other problems that we need to do. I'm going to stop recording this right now. It doesn't seem like you had any